All right, well, it is 11 a.m. Pacific time, so we'll go ahead and get started as people trickle in. Hi, everyone. My name is Dillon Connolly. My pronouns are he and they. I'm joined by my wonderful colleagues, Claire and Adams and Sky Reed Mills, and we are so happy that you can join us today for this STEM Activity Clearinghouse collection unboxing webinar for the SEAL Solar Eclipse Activities for Libraries collection on the STEM Activity Clearinghouse. I'm gonna go ahead and get us started today. All right, so here is our agenda for the day. We're gonna go a quick introduction and icebreaker. We'll be going over some quick project information for the SEAL project and sharing some resources. And all of these resources, anything we're sharing out today, will be available in the link bank that our Sky is going to be sharing out in the chat throughout the webinar. And then we'll be going over quickly the SEAL collection on the STEM Activity Clearinghouse. And we're going to be demonstrating and explaining 6 different activities, kind of under 3 different themes. Today, we're going to be going over a couple of quick science demonstrations, some passive paper crafts that you can do, as well as some more involved project activities. And then at the end, hopefully we'll have some time to open this up for a Q&A for y'all to ask any questions you have about the collection or any activities we're covering today. So I will go ahead and hand this over to Claire to introduce herself and go over our icebreaker.
Hi, everybody. Thanks for joining us. My name is Claire Adams. My pronouns are she, her, and I'm an education associate at the Space Science Institute doing a bunch of the professional development for the SEAL project. So as an icebreaker today, I thought we could tap into our inner solar features. And what solar feature do you feel like today? So number 1, and you can just put this in the chat. Number 1, are you feeling like a sunspot? Relatively cool, calm and collected, embracing change and transition. Sunspots are temporary. They can last from a few hours to a few weeks, and then they change. So maybe you're in a moment of flux, but you're feeling kind of nice and cool. Or are you a solar prominence? So this is a showy and bright feature from the sun that is a large arc of plasma that's generally connecting to sunspots. So you're showy and you're bright, but you're staying within, your comfort zone a little bit. You're grounded, you're connected. Or are you number 3, a coronal mass ejection? These are, or you might know this as a solar flare. This is large amounts of energy burst off of the surface of the sun into the rest of our solar system. So maybe if you're feeling powerful and influential, or maybe ready to mess things up, because coronal mass ejections can actually interfere with objects in space. It can interfere with stuff on Earth, like our satellite signals, and it can have a real big impact far, far away from where they originated. Or number 4, the sun's corona. Are you feeling maybe gassy and sassy today? The corona is the sun's atmosphere, and it is fully visible during a total solar eclipse. So this image here is actually a picture of a total solar eclipse when the sun is completely covered by the moon, and you can actually see the what's happening with the atmosphere. So maybe today you're not going to let anybody's shadow dim your light. All right, so got lots of answers in the chat over here. Lots of sunspots. All right, feeling cool, calm, and collected. That's great. Dylan, definitely feeling like the sun's corona, always sassy and occasionally gassy. Awesome. Yeah, lots of sunspots. We've got a solar prominence. A few solar prominences. Great. And a corona. Not going to let anyone step in the light of yourself. Cameron is ready to mess things up. I love it. And Leslie is going to be weeding later. So coronal mass ejection, she's going to get out there and change things out in her yard. All right, and lots more sunspots, prominences. Ooh, and someone added a new response. Michael says, with the weather today, I'm feeling more like the core. Awesome. I almost put the core on here as an option. The sun's core is the hottest part of the entire sun. One of, I think, the hottest part of our entire solar system. So yeah, if you're feeling the heat today, the core might be where you're at. And Noreen's has a little bit of everything. Absolutely. As the day moves on, you know, we can be dynamic, we can change, just as the sun is dynamic and changes all the time too. Awesome.
I
Well,
agree with Michael. It's been so hot all over the country, especially along the coasts. And I know that as we're getting ready to prepare y'all for the eclipses, I'm definitely feeling the pressure of the core of the sun as well. So we're really, really glad that y'all could join us. And hopefully sharing some of this information with you will relieve some of your pressure for preparing for eclipse programming. Well, thanks for that, Claire. If you're unfamiliar, this webinar is one of many in a virtual training series we're doing for the SEAL project. SEAL stands for Solar Eclipse Activities for Libraries, and we've gotten generous funding from the Moore Foundation to do all sorts of great stuff to prepare libraries for the upcoming eclipses in October of this year and April of next year. We have a great annular eclipse coming up that's going to be visible kind of from the west coast down to the east, down to South Texas, coming up in October. The annular total eclipse is, of course, when the moon doesn't completely cover the sun and you get a ring around it called an annulus. And then in April, we are getting a total solar eclipse, similar to what happened in 2017. If any of y'all participated in 2017 eclipse programming for the Great American Eclipse. And that path of totality will be traveling from South Texas to the Northeast. So what we are doing to prepare libraries for this project, for these upcoming eclipses, is we are providing free eclipse classes for libraries. We are currently about to run out of our first batch. We do have some available. The link to apply for those classes is in the link bank that Sky is going to be sharing out throughout this webinar. We are also providing in-person trainings. We are attempting to get all 50 states. I think we have scheduled for 46. I think we're almost to our goal there for scheduling in-person trainings in 50 states and 4 territories. We're also doing recorded training videos and virtual workshops, just like the one you're in now. We're going to be circulating kits to state libraries. And these circulation kits are meant for your library to check out from your state libraries with solar telescopes, books, hands-on activities. You can find all about those kits in our Getting Started with SEAL webinar, which is linked in the Getting Started with SEAL blog post, which is also linked in the web link bank for today. We are also providing access to scientists, volunteers, Eclipse subject matter experts, and other librarians to the StarNet online community, which you will be automatically registered for when you apply for classes, even if we don't have any classes available. So highly recommend getting that application in. So that is the SEAL project, and we have some amazing resources that we are sharing out, which Claire is going to talk about a little bit now.
great, thank you. Yeah, and we can move to the next slide here. So the big resource I want to share with you today is the STEM Activity Clearinghouse, focusing on the SEAL collection. So if you haven't heard of the STEM Activity Clearinghouse, you can access it at www.clearinghouse.starnetlibraries.org. This is a database of over 500 hands-on STEM activities ranging from pre-K all the way through adult programming. So we hope that this is a resource you can use well after the eclipses, because there's all kinds of stuff in here, and it's not all just space science. We have citizen science, earth science, water-related activities, but all of these activities have been vetted by the StarNet team for accuracy of science content, and most of the activities we've tested in libraries too, to make sure these are appropriate for library educational programs. Next slide, please. So this is what you see when you first go onto the clearinghouse. This is the homepage, and there's a couple different ways you can find your activities. There's the browse and filter all activities, which will take you to all 500 activities with a sorting toolbar. But we also on the main page have our featured collections. Next slide. These 8 featured collections are projects that we're currently being funded for. So if you're a part of any of these projects, you can find them here. But you can see we have the Solar Eclipse Activities for Libraries collection with our little seal. And that is where you can find all things related to eclipses and solar science as well. Next slide, please. Oh, and there it is. In case you had trouble finding it, there is the seal collection. So in this collection, as I said, there are solar eclipse activities such as, we have big sun, small moon, which is a demonstration about perspective and distance that really helps teach little kids, how is it possible that the tiny moon can cover the big sun? And this goes into just, why that appears to be that way on the day of the eclipse. There's eclipse chalk art, which is a great STEAM activity where you're creating a picture that shows the sun's corona, that atmosphere of the sun. There are guides to building solar eclipse viewers, which Dillon will be showcasing later. And there's a number of different ways you can do that, such as using a shoebox or multiple sizes of boxes, as Dillon will show. Next slide, please. There's also just general solar science activities. So these are great anytime if you just want to teach, explore what is going on in our solar system, in our universe, and how, the sun is impacting even life on Earth as well. So there's Pocket Solar System, which is a really fun and easy way to talk about the scale, how close some planets are to us in comparison to, the sun, or to some of our gas giants, which are even farther away from us than the sun. But it's a nice little way for people to understand the scale in a pocket size manner. There's also UV Kid, which explores different types of ways that you can protect yourself against the sun's UV rays. There's Make Your Own Sun Clock. Again, this is just a little sundial. We'll be showing this later, but you don't have to have this just for the eclipse. You can make these tomorrow and talk about how humans have been using the apparent passage of the sun throughout the sky to tell time since the start of humankind. And then there's so a solar energy quick facilitation guide, which is a really fun demonstration to talk about sunlight absorption and the retaining of heat. And Dillon will show that later. So not just eclipse stuff, but we have solar science as well. Next slide. And then finally, we have a number of passive activities. These are great activities that you can just print out a table sign. Everything here is available in English and Spanish. Put out the materials on a table, and you don't even have to facilitate it. You can put these out as stations or do something. These are great take-home kits. So there are a number of different passive activities as well. And finally, I do want to say every activity is available in Spanish, not just the patron-facing materials, but the activity guides as well. As Dillon said, we are going to 4 of the U.S. territories, and that includes Puerto Rico. So we are working with Spanish-speaking librarians, and so these are all available, English and Spanish. And if any of them are missing a Spanish translation that you want it in Spanish, just let us know. And we have an in-house Spanish translator. So we want to make sure all of these are accessible as much as we have the capacity to do for you. And then the last thing I want to say about the clearinghouse is, yes, we have the activity guides. Many of them come with how-to videos. But if you scroll down underneath the activity, we're trying to put together additional resources for you to consider to really round out your program. So we've included hints for use in your library, related links that has the background science content, the originating source. We did not make all of these 500 activities. We partner with other organizations around the country that do really excellent science. So if you find an activity that is just fantastic and you want more of that, you can go into the originating source and find more information about that. And we put together a book list. So if you are doing a story time program or want to put a book display together as part of your program, check out these resources as well. All right, and now we're going into activities. We do have a question in the chat. So when one filters the solar eclipse activities for libraries to find Spanish, only 3 Spanish display. Thank you for bringing that up. We can fix that very quickly. So yes, we will fix that. And thanks for bringing that to our attention.
Yeah, thanks, Cameron. That's probably just an issue with the tags, and I didn't even realize that was an issue. So thanks for bringing that to our attention. We'll make sure to get that on that right away. So now we're going to start talking about some of the activities available in the collection. We're going to be demonstrating 6 of them today, but there are many more in the both the seal collection and on the clearinghouse itself. So hope you dive in and explore some of these activities beyond what we're talking about today. And the first one we're going to be talking about are those demonstrations I was talking about. These are pretty simple demonstrations that you can either have passively on a table to be observed or demonstrate yourself with some of your visitors. So the first is going to be a pocket solar system. So this is a pocket solar system that you can do by folding any long strip of paper. For example, register tape is really great for that, like this one that I've got right here. All you got to do is you break off a strip of paper, and it doesn't matter what length it is. I mean, it has to be fairly long, but not too short. But the exact size doesn't matter because you're going to be folding it in a certain pattern that's available in the activity description. And when you fold that, those folds will represent different distances from the sun, which will be on one end of the piece of paper, going all the way out to the Kuiper belt at the other end of the paper. So the full expanse of the solar system. And those folds will represent the scales between them. And you can learn about those different measurement scales because we provide those in both miles, kilometers, and what are known as astronomical units, or AU. And AU is the distance between Earth and the sun, and astronomers use that as a kind of shorthand to represent different lengths, to kind of represent the distance of something from the sun. So for example, Saturn is 9.5 AU, which means it's 9.5 times the distance from the sun that Earth is. And it's a really fantastic activity. It's very, very simple. All you got to do is follow the instructions to fold your strip of paper into the scale model of the solar system. And we also are providing these really, really fantastic planet cutouts. So no matter what size of lengths of paper you're doing, these are really great to decorate. These also are a really great resource, these cutouts, which include little factoids about each one feature of the solar system. For example, the asteroid belt, it mentions that we have 2 rocky asteroid belts, one between Mars and Jupiter, and the much larger Kuiper belt that's beyond the orbit of Neptune. Kuiper belt objects include things like Pluto, which is a planetoid that used to be classified as a planet, but is now classified as a smaller object called a planetoid that is part of the Kuiper asteroid belt. Things like Mercury being the smallest and closest planet to the sun. We all have these representations that you can attach to that pocket solar system. This also makes a really fantastic take and make kit. I'll be showing an example of a library who did that later, where you can take the strip of paper, include the page of instructions on how to fold that, and copies of these cutouts, and send that home for patrons to learn on their own. So really, really fantastic, easy activity, especially for younger learners through like upper elementary who might not be familiar with the solar system or learning about the solar system for the first time. This gives a really great idea of the scale of the solar system and our position in it relative to the sun, which is really important to understanding how the eclipse works. So that's the pocket solar system activity. We also have one that demonstrates solar energy. So eclipses are all about the sun's light, which is a type of energy, and how that is blocked or not blocked at different points during the eclipse. So a great way to learn about the sun's light as energy is to do this really simple demonstration. So this demonstration requires you to have 2 empty plastic bottles of the same size. Soda bottles work great if you're looking to do this activity or kind of want everybody to make their own solar energy activities. Asking people to drop off recycled bottles and pairing those up in 2s as a donation would be really fantastic. What you're going to do is paint one of them black and one of them white, and then cover both of them, top both of them with a balloon. You do not need to put anything in the water bottles. All you need is air inside those water bottles. And if you want to make sure that that seal is really nice and tight, just go ahead and use some flexible tape like duct tape or electrical tape just around the rim of the balloon where it attaches to the bottle to make sure that seal is nice and tight. And what happens is when you put these out in the sun, it doesn't even need to be a crazy bright day, it just needs to be a relatively warm, bright day. What you'll notice is that the black bottle, and here you can see in this diagram, the black, when these bottles convert solar energy into heat. So what happens is the black bottle absorbs the solar energy. The pigments in the black paint absorb all of those colors, while the white bottle reflects it. And so what'll happen is as that heat, that solar energy is absorbed by the black bottle, the air inside, the molecules of air get excited and they start to expand as heated air has a greater volume than colder air. So as that temperature rises and that air expands, it's going to fill the balloon at the top of the black bottle. What happens with the white bottle is just like when we're wearing a white t-shirt on a really, really hot day versus a black t-shirt, the sun's light is reflected off of that, and that energy is not converted to heat inside the bottle. So the balloon does not inflate. And this has some great real world connections beyond just thinking about solar energy and heat. Although you might notice that the temperature drops during your eclipse programming, that the temperature drops a couple of degrees as the eclipse continues, as you're getting less light from the sun. But we also has real world connections to climate change. There's lots of architects who are exploring energy efficient architecture. One of the great ways that urban areas are dealing with increased temperatures for climate change is doing things like painting the roofs of buildings white to reflect more heat so that air conditioning and other cooling technologies aren't necessarily necessary for the building. Oh, I see a question in the chat sharing us. How full do you feel the bottles? Actually, the bottles can be completely empty. All you need in these bottles is air. So actually, I experimented with this because I was worried about the bottles being too light and me leaving them out and getting blown over with a breeze. I would recommend taping them to whatever surface you're doing rather than filling them with water. If you put any water or anything or liquid in the bottles, what happens is the water can mess with the temperature. Water doesn't evaporate and get as excited as plain air, so it'll actually impact your ability for the bottle to inflate. So you don't need anything in the bottles, just empty bottles topped with the balloon. So that is the solar energy activity. Those are two great simple demonstrations that are great icebreakers or warm-ups as you're thinking about eclipse programming. Really great ways to get people thinking about the sun and solar energy and our position in the solar system. So next we'll be going over some passive paper crafts, and I'm going to be handing this back over to Claire.
Thank you. Yeah, so these are some of those activities that all you need to do is have a printer and some paper. So first we have the Eclipse glasses case, and next a DIY sun clock. So next slide. So the Eclipse glasses case or solar viewing glasses case is a template for patrons to make a personalized protective case to keep their solar viewing glasses safe. So this is really great because if you're ordering glasses from us, it's a one-time order. So whatever you order now, you will need to use for the annular eclipse this October and also the total solar eclipse in April of 2024. So it's a way to encourage patrons to hold on to their glasses. And it's also an opportunity, if you do some programming around it, you can discuss safe viewing of the eclipse as well. And finally, our graphic designer made it to be a commemorative item for folks to take home that connects the two eclipse events. So on one side of the template, you have the date of the annular eclipse along with a little diagram that shows that ring around the moon that is the annular eclipse. And then it also has Monday, April 8th, 2024 with a little graphic that shows the corona of the sun. It can be passive. Absolutely. We have table signs in English and Spanish that have all the instructions. All you need to do is print out the templates and have a stapler. That is the one material that you need for it. and maybe some markers, something for the kids to color it and write their name on it. But like I said, if you want it to be a part of a safe viewing program, you can have this at the end of the program when you hand out the glasses to folks, and also have them create their own little case to take home. But it's very low cost and essentially all just printable materials. So next slide, please. Here is the table sign. So it has the diagram of what the template should look like once it's actually created and how to slide the glasses in the case. And then it has 4 easy steps for creating it. So basically you cut out the template, you fold as directed. There's instructions and there's little lines to show you exactly where to fold it. Add your name and any personal designs to the outside of your protective case, and then just slip your solar viewing glasses into the protective case for safekeeping. It's also an opportunity for you to talk about, if you're holding on to these until April, let's do some checks to make sure it's safe. And it's very easy to do that. You just take your Eclipse glasses and you just hold them up to some light. It could be inside, it could be outside. And if any light is shining through, if there's any cracks or holes, then it's no good. Or if the frames have come apart from the lenses, it's probably not safe anymore. But other than that, these do not expire. The materials don't break down. They will be fine for April as long as they're put in this nice little safe case and maybe just kept in a drawer or a folder somewhere. All right, and the next slide. This is what the template looks like. So the instructions are printed out right there on the template. So you can give them out to families. There's it's all just 1 page per case. And then this is what the final product looks like. I've gone ahead and decorated the front. There's a spot to put your name. And on the other side here is where you have that commemorative information and the graphics of the annular and solar eclipses. So you just cut it out, you fold it in half, and you staple the top. And then you have this nice little pouch where you can slide your glasses in for safekeeping between the 2 eclipses. Again, great passive program, or tie it into a solar safe viewing program as well. And we had a great question in the chat. I'm just going to read it out loud so those watching the recording can see it. When will we hear if our glasses application is approved, or do they just show up? And Sky responded, we will send you a welcome to Seal email after your order gets approved. It can take us quite a long time to get those sent out because I think we have, after this grant, I think gave us about 5 million glasses, and we've gone through those pretty quickly. So we were able to get some extras from other funding agencies. So that's just a lot to go through, a lot of orders that we hand go through, and we're not a huge team. So it may take a few weeks, it may take a month, but if you do have questions, email any of us on the team and we can give you an update on that. And it looks like Sky is the person to contact for that at sreedmills@spacescience.org.
Yeah, we are doing our best. It's first come, first serve, and there's been a lot of first comers. I think we've broken 3,000 libraries have applied for glasses. So we are working our way through those. And so please be patient. If your application is complete, including a letter from your administration saying they are aware of the project, then you should be receiving glasses. It just might take us a minute to get to that application.
Awesome. All right, now the next passive program that we'll be sharing with you today is Make Your Own Sun Clock. So this activity uses the sun's orientation in the sky to tell time with this pocket-sized sundial. So you can see a finished clock here on this picture. On the next slide, we'll show you that it comes as well with a table sign. So available in English and Spanish. You just need to print this out and display it along with the templates that you'll need to print out as well. It has 3 easy steps. I do encourage you for the templates to print them out in cardstock. So when you fold it, they just stand a little bit easier. But I have done this with regular paper and it works great too. But you just fold along the dotted line. making sure the print is on the inside. So the face of your clock is on the inside of that fold. Then you will need for this string. So that's one other material that you'll need to have. About 7 inches of string should work. There's little notches in the top and the bottom of the sun clock. You just fold that, just kind of pinch the string through those little notches, tape it to the back, and then you use your sun clock to tell the time. So I have one right here. You can see it's really small. It folds up. It can go right into your pocket. We call it, it's also known as a pocket sun clock. But here's my string. And on the inside is the face of your clock. So it has the different numbers. And so you want to hold your clock. I'll get rid of my filter back here. So let's get rid of that so you can see things a little better. Hold on, computer is not wanting to get rid of my filter. All right, I'll do my best. But you want to hold your clock facing you when you go outside, just on the palm of your hand. And then you just start turning your body around until the shade of the string is falling onto one of these lines. And then use a regular clock, you know, to test the time, make sure it's the right time. Once you have it so that the shadow is facing, telling the correct time, it has a bit of a inquiry project built into it. So then once you have the time, it asks, what direction do you need to face for this sun clock to work? So then it's great to have a compass out there if you have one. Most smartphones come with a compass. And so it's a little bit of an orienteering activity as well. And the kids can figure out, you know, what is the direction you need to face. I am not going to give you the answer. The answer is in the activity guide. But if you want to try it out for yourself and test it out, let us know, what direction do you need to be facing in order for the shadow of the string to tell the correct time. And do note, daylight savings is taken into consideration here. If it is Sunday, March 13th through Sunday, November 6th, which is what we are in currently, you need to subtract 1 hour from what your sun clock is showing you to get an accurate time. All right, and here's the template. So again, I would print these out on cardstock. You can have, if you have older kids there, or parents or guardians, they could cut it out themselves. Or if you want to save that time and not have to deal with a bunch of paper scraps, cut them out ahead of time and just have them out with the table sign, with a string and some tape, and maybe, you know, a compass if you would like to get kids to think about direction. Do note that we all live in different time zones, right? So depending on where you live, it's going to be a different time. So we have arranged these to reflect that, and you just want to make sure you're printing out the correct template for your location. And you can see on the corner of the template there, it says use this sun clock if you live in, and then it lists the different states and even portions of the states where this sun clock will be accurate in its time. That's it. It's really fun and simple. Kids get to take it home, and it's a way, you know, just to connect them to how humans use the sun in so many different ways, of which one of which is telling the time.
Thanks, Claire. Yeah, and what's great about these activities, these passive paper crafts, is they're not if you do want to use them for programming in-house, if you're hosting a safe viewing education party or an Eclipse education daytime star party to learn all about the sun as a star, it's a great opportunity to have some crafts and activities that people can take things home. Or depending on your capacity, if you do not necessarily have a ton of programming capacity, do live programming preparing for the Eclipse. A lot of these activities make really fantastic take and make kits. So on screen right now is actually an Eclipse display that was just shared with us on our StarNet community group by one of our partner librarians. And they have actually taken 3 of these activities: the sun clock Claire was talking about, the glasses case, and the pocket solar system model, and they have turned those into really fantastic take and make kits that patrons can take home. The take and make kit for the Pocket Solar System includes a strip of paper and the print instructions and the cutouts for all of the different planetary features. The sun clock includes the printed sun clock, the instructions, as well as a piece of string, and then the glasses case provides just a cuttable printout of that glasses case. So these are really, really great ways. You can also set this up as a display, take and make kits that your patrons can take home if you aren't, even if you don't plan on using these during programming. So that's another thing to think about if you're thinking about using some of these activities, is that they aren't just great for live programming, but also for take and makes as well. So the next set of activities we're going to be talking about are some of the more complicated project activities. Now, these are definitely meant for a little bit older learners. I would say these are probably upper elementary and up, great for multi-generational learning if you're planning on doing family programmings, especially if you've got some older family members who can help out with younger members. There's two that we're going to be talking about today. We're going to be talking about a Pinhole Eclipse viewer, which has an extension for a design challenge as well as how to make a solar oven out of a pizza box. So the first one is going to be we're going to be talking about is that Pinhole viewer. So if you participated in the 2017 Eclipse, you might have seen some advice about how to view and project the eclipse through something like a colander or a small pinhole. If you have a makerspace, I know that NASA made individual state pinhole viewers, 3D printable, available. All of those use the same concept, which is creating a camera obscura. This is a really old scientific concept where light from any source is concentrated through a tiny hole called an aperture. Through that aperture, it is then projected outwards onto a viewing screen. You can kind of see a diagram of that example on screen right now. What happens through that camera obscura is that the image is reversed. Although when we're talking about viewing the sun, it's not a huge deal, as you're not going to be getting a ton of obfuscation from that image being flipped upside down. So the most simple version of this pinhole viewer that we have provided instructions for, we're telling you to make it out of a cereal box or any box with a long edge. And then you just need something sharp like a craft knife or scissors to cut out different parts of the box, some tape to attach some stuff to it, a strip of white paper to use as a projection screen, and then some foil to create your aperture. So what you can do here is before I go into the actual instructions, I'm going to stop this sharing and show you on camera. All right, so this is a very simple version of an Eclipse viewer that we have designed, and this is actually the one from the instructions. So you are seeing the OG right here. So there's three parts. For any pinhole eclipse viewer, you need a viewing window, which is something for you to look into, an aperture, which is that tiny hole, that pinhole that's going to concentrate that light and project it. And if you look in back here, we've actually put a white strip of paper on the back there that's going to be your projection screen. So those three parts are what's essential for any pinhole eclipse viewer that you're building out of a box, is that the screen for it to be projected on, the aperture, and the viewing window. So all you'll do is, after you built this, is align the aperture with the sun until you see through your viewing window the eclipse projected onto that projection screen. Switch that camera again. All right, and back to the screen sharing. All right, so as I said, you have those three parts of any projection screen. So you're gonna have the projection screen, the aperture, and the viewing window. So to create this is I just cut open the back of the bottom of that cereal box, put that strip of white paper there to use as a projection screen. I cut out two holes, just like the viewing window, covered one of them with some aluminum foil that creates the dark area that will create the aperture, and just used a pencil to poke a tiny hole to use as an aperture. And then you look through the viewing window. So here is an example of what this will look like when you've aligned it correctly. As you'll see the eclipse projected onto that projection screen through the aperture, and you'll be able to see it through the viewing window. This is a really great way. We know that glasses are always in high demand. This is a perfectly safe viewing method because you're not looking directly at the sun. You're using some very simple science to create a projector and a camera, essentially, to view the eclipse through. What's great about this is you can also take this activity, and instead of using a cereal box, you can use this to create a design challenge. This is really great if you've got some middle school or up learners, where you can ask your patrons to donate boxes of any type. For example, here is a big box retailer, an online retailer box, who shall remain nameless, that I've also turned into a Eclipse viewer, and you can play around with the positions of the aperture, the projection screen, and the viewing window. So while the cereal box, the viewer that I just showed you, the viewing window and the aperture were kind of on the same side of the box, depending on the shape of your box, the length of the box, the different dimensions, you can mess around with putting that viewing window, for example, perpendicular to the aperture. Here you can see I've put that, this is a shorter box, more of a square box than the rectangle box. So I wasn't actually going to get much of a view putting that viewing window next to the aperture window. So I cut it in the side so I could line that up and look sideways into the Pinhole viewer. And I can actually show you what that looks like again. Here you can see I've just taken the box. So here is the aperture. So this is what you would line up with. I've cut this square out of the box and covered that in foil and tape. I've also, to help light from leaking into the box, I've covered any seams I have on the box or any parts of the box I might have had to rip open with black paper. You can also cover those with foil. And then the viewing window is right here. So I would be aiming this side at the sun and looking sideways through here. So you can play around. You can have learners play around with all sorts of positioning on this. You could use gigantic boxes and have your viewing window actually be something you put over your head. That's something I've seen learners do. And you can experiment with, what does it change? How does it change the view of the eclipse or the sun if you have a longer distance between your aperture and your projection screen, which the projection screen is on this end right here opposite the aperture. As long as your viewing screen is opposite the aperture, that viewing window can go anywhere and be any size. You can play around with different sizes to see how that affects the light that leaks into your Eclipse viewer. You can cut and tape boxes together to create extra long viewers. One thing you'll notice is the longer you create the distance between the aperture and your projection screen, the larger the projection of the sun is going to be. So there's a lot of fun you can have with this science and exploring how the shape and nature of your Eclipse viewer really changes the projection of the Eclipse viewer that you're making. So that is the Pinhole Camera Obscura Eclipse viewer. We also have included, this is my favorite activity in the SEAL activity collection. I had a lot of fun designing and testing this. This is a pizza box solar oven. What this does is uses any pizza box. I ended up, if you can use a used pizza box, absolutely. It might smell a little funky after a few minutes, after a while. But what I did to actually test this was I just went to some local pizza chains, told them I was designing this activity for learners to learn stuff about the eclipse and make a solar oven out of pizza boxes. And I was able to get from Domino's, Pizza Hut, and a local chain, like about 10 boxes each from each one of them. And so this is a great opportunity for you to reach out, get the community involved, get some local places to donate some pizza boxes, because all you need is some sort of relatively pizza box shaped box with a lid in order to do this. And what the scientific concepts here are, you're going to use aluminum foil, plastic wrap, and some tape or glue to create, and black paper to reflect the sun's light into the solar oven. Then the black paper in there is going to act as a heat sink, which is going to convert that solar energy into heat, just like the solar energy activity. So if you're thinking about pairing some of these activities, that solar energy bottle demonstration is a great way to demonstrate the science behind solar energy, converting that light into heat before you build your solar oven. And then the retention, the open area right here, I will be showing an example of this on camera in just a second. It's a little hard to see here, but that opening is actually covered with plastic wrap, which traps that heat and retains it inside the solar oven. So I'll show you an example a little more close up of how this works. So here is what the solar oven looks like when it's complete. The instructions are in there. All you got to do is you cut this window out, cover that window, that lid with foil. You line the inside of your box with foil and create your heat sink with some paper. And then prop that up with some chopsticks, popsicle sticks, any craft sticks you have. You could even use a ruler if you wanted, and tape that to the lid to prop that up. You just want the angle of your lid to be reflecting light down into the solar oven yourself, and it will work fantastically. If you want to make sure, if you want to check the temperature, you can even put a little temperature probe if you've got a digital oven probe in here, or what we used when we were testing it is we just got a simple $3 oven rack thermometer from Walmart, and we were able to put that in there. So what's great about this activity is it works like this. As I said, here's a great diagram demonstrating how this works. The sun's light is reflected off of that foil on the propped up lid, and that's reflected into the solar oven itself. And once it's reflected in there, that black piece of paper converts that energy into heat, and that heat is trapped by the plastic wrap and cooks the food that you want to. So this activity actually includes 3 different recipes that we've included for you, which are all adaptable and easy to use. All of these are also food safe. You do not need to cook these to a certain temperature in order for them to be edible. You are just heating them. So if you are having a semi-cloudy day or anything like that, you're not worried about cooking any meat through or anything like that. So the 3 recipes we've included are Nutty for Solar Science cookies, which are some cool either bake or no bake cookies made out of bananas, oats, a nut butter. If you're concerned about nut allergies at your library, you can also use something like sun butter or any sort of seed butter as well. And then some chocolate chips. You just mush the banana together, mix all the other ingredients, you drop them into a baking container and put them in your solar oven. When I was testing this out, it was about a 85-degree day, and those cookies cooked in about 10 minutes in my solar oven. The solar oven got up to about 180 degrees, which is pretty hot for something you've made out of cardboard. We have printable recipe cards for each. So once again, if this is something you wanted to solicit donations for materials, like get some flat pizza boxes, some popsicle sticks, or chopsticks, you could send these the supplies home as a take and make kit with these recipe cards. Or it's a really great passive activity for if you are doing some Eclipse learning. If you're not in the path of totality or annularity, where the sun's going to be completely covered and you're still going to have a lot of the sun visible, for Eclipse Day activities, you can have people build these and make them by having the supplies out there on tables. So it's both a activity that's facilitated, or you can have it as a passive activity as well. One thing that's great about this activity is we've also included an extension. One thing is you do require a pretty clear sunny day in order to get the temperatures to really cook some stuff in your solar oven. But if you do not have that, or you're in a cooler area of the country, or you just want to reuse this activity after you've built that solar oven, is you can turn it into what's called a solar still and explore water purification through evaporation. So all you got to do there is build the solar oven as is, and put inside 2 containers, one smaller than the other. Put some dirty water. I just took some water and threw some potting soil in there, and a smaller container on the inside of that, and just weigh it down with something like stones or something just to provide a little bit of sag to the plastic wrap on the top of your solar oven. And what you'll see there is, even putting this outside on a cloudy day, the reflection and retention inside that solar oven will cause that dirty water to evaporate, collect on the plastic wrap, and drip down into the clear container. And you'll see that the contaminants are left behind outside, and you've distilled the water and purified it into that interior container. So that's a really, really fantastic activity. I love the solar oven, Pizza Duck solar oven. I've used it a couple of times just messing around on some weekends with my friends, just to show them something neat. It's a really, really fun activity. Hope you guys enjoy messing around with that. So we thought we would give this number. Claire, I'll hand this back over to you, and you can talk about, you can ask this question.
Yeah, we'd love to hear from you now that you've seen these 6 activities. Which of these activities would you like to run at your library? And you can put all that apply, and you can just type them in the chat. But just as a refresher for what we went over today, we had our pocket solar system, solar energy demonstration, the solar viewing glasses case, sun clock, the pinhole viewer, and the solar oven and solar still, which Dillon just went over. So take a minute to think about it. But we'd love to hear which of these kind of resonated with you. Which of these are you excited about doing with your community? Awesome. Marianne says all of them, including that still extension. The water purification, that's coming through as very popular.
Where's the information for that exactment?
Oh, let me send it to you.
Okay.
All right. Pocket solar system sun clock. Yes, those are just really easy, simple stuff. If you're busy and you don't have time to facilitate a big program, those are excellent. All right.
And while y'all are sharing that in the chat, I'm going to tell you just about a couple more trainings that are coming up on in the next month through the SEAL program. All of the links to register for these upcoming trainings are in the link bank that Sky has been sharing throughout the webinar today. But we are having a open-ended Eclipse Ideas Share-a-thon on September 12th. Myself and Stephanie Vera Fields, another colleague at SSI, it's going to be an open-ended kind of freewheeling discussion, inviting librarians from all over the country to share out their ideas about what they're doing, seek advice from each other, share resources, either from SEAL or elsewhere. It's going to be a really, really cool discussion, we're hoping, about Eclipse ideas directly from y'all, the librarians, the folks on the ground who are going to be doing this programming. If you're thinking about Eclipse books and acquiring some Eclipse books for your either some book displays or reading challenges, anything like that, we are going to be doing a webinar with a bunch of different authors of Eclipse books. And these books are going to be running from anything from storytime books for young learners to adult readers. That's going to be on September 12th. And the big one, what to expect leading up to Eclipse Day, that's going to be on September 27th. So as you're scrambling last minute, if you're planning on for the annular eclipse, or just want to get a head start for thinking about what to prepare for the Eclipse Day, for the total eclipse in April, we are going to be going over, we sent out a fantastic survey and got a ton of responses from librarians who participated in 2017 for the Great American Eclipse, sharing their insights on things they wish they'd known before Eclipse Day, stuff to prepare for, how to manage crowd management, what to do if you run out of glasses well before Eclipse Day, other safe ways to view the eclipse. Tons of great information about the last minute preparations and day of emergencies that you might come into as you're preparing for Eclipse Day. So those are those upcoming trainings. All of that registration information is available in the link bank that Claire just shared. And now we've got about 7 minutes left. We thought we'd open this up. I know that we've had some fantastic questions in the chat throughout the webinar, but now is the time to, if you have any questions, either throw them in the chat or we can keep it pretty casual. There's not a ton of us. If you feel like unmuting and asking your question, go right ahead. So let's open the floor to any questions y'all might have.
So we have a question about, Cameron shared, we were thinking it would be great for adults to learn a bit of Spanish for key terms like measurements, etc. Will those particular activities be translated into Spanish? I didn't see them in Spanish in the clearinghouse. So I do know the Eclipse viewer activity that Dillon demonstrated is still in the process of being translated. So all of these should be up, you know, by the end of September, I would say. But feel free, I work very closely with our translator. I'll put my email in the chat. If there's a specific activity that you don't see with Spanish translations, let me know and we can work on getting that translated. So my email is cratcliffe@spacescience.org. I also want to share what Christine said. Christine did the solar oven activities and kids and families loved it. They made s'mores, supply bags to send home, and take and make so families could cook on their own at home. Not enough time to create and cook at the library. That makes sense. They also did a short 5 to 10 minute discussion about the sun and its importance and showed short videos about solar eclipses prior to making the ovens. It's a great way to connect it to the eclipses. Love it. And sent everyone home with glasses. Yeah, we do encourage you to pass out the glasses at the end of a program. That's just something we've heard from librarians that helped with just managing the distribution of glasses so that folks just don't show up, you know, demanding glasses. You know, it's a way for them to get some information from you, attend a program, and a way for you to have it not just be a free-for-all grab for the glasses.
Absolutely. I think that's a great point is I know that we're talking about activities today, but as you're getting your glasses, I know that right now applicants are getting a maximum of 500. And obviously there might be more of an interest than 500 people for acquiring glasses. So this is a great way for if you want to do some family multi-generational programming. Glasses are shareable during the event of the eclipse. So you can do something like one set of glasses for family participants in a program, and they get those at the end of the program. Or you can, you know, have people take, you know, they can be included in a take and make kit if they've signed up for another program as well. So you can have those glasses perhaps with a take and make version of the glasses, protective case, something like that. But I think it's a really great idea to distribute your glasses through programming rather than separating them. Cameron just asked, are there any tips for doing programs further in advance to get people engaged with the upcoming eclipses? We are thinking that people can do the cases in September, bring that back in October for the actual glasses. Absolutely. We did actually a set of trainings earlier in the spring, and those are all available on our YouTube channel. They're also linked in the Getting Started with SEAL blog post that's both in the link bank for today's webinar and has been shared out in the chat. But we had a whole series of webinars about citizen science and how to do daytime star parties incorporating citizen science in advance of the eclipse or between the two eclipses to take advantage of interest that might be sparked by the October eclipse for the April eclipse. So we have a ton of great ideas there. Also, the state library circulation kits that I mentioned earlier, which you can find out more about in our Getting Started with SEAL webinar that is also linked in that Getting Started with SEAL blog post. The solar science circulation kits are actually designed to be used by libraries not on Eclipse Day, but leading up to or after Eclipse Day. So those kits have those solar telescopes, fun activities, and storybooks in them. So contact your state library so you can get. Each state is handling the circulation of those kits differently, but that is a great idea for programming leading up to the eclipses. If you can get your hands on one of those state library circulation kits as well.
Yeah, I know we're working with some libraries that have started doing programs already. There's one in Texas doing a solar science Saturday once a month, just giving information about the eclipses, you know, the difference between the annular and the total, and trying out some of these activities each time. So that just, you know, builds up that enthusiasm and gets folks prepared for the actual events.
All right, and I think as that's a great place to leave it. We have that's our hour. So please, if you have any questions about any of the activities we've shared today, please don't hesitate to reach out to myself or Claire. I'm going to put my email in the chat. It's dconnolly@spacescience.org. I'd be happy to answer any questions you have about the activities, our upcoming trainings, anything like that. Please don't hesitate to reach out. I hope y'all got something out of this hour. I know I had a lot of fun sharing these activities. It was great developing them for libraries, and we really hope that you take advantage and use them, and they enhance your programming and get your patrons excited about solar science and the upcoming eclipses. So thanks so much for joining us today, and we hope to see you in some of our upcoming trainings. Have a great rest of your Tuesday, everyone.
Bye.